asked you guys to walk through this one here. And one of the things, your strategies and goals and stuff that as you're doing or trying to try out a proof is you always want to read the givens and see what they're trying to give you. Look at the diagram, make any markings within the diagram if possible, and then look at what they're trying to have you show at the end before you go through the steps they're giving us. So far this week, everything that we're going to do is going to be all fill in the blank style. Okay, you're not having to do anything that come up with it on your own. The only on your own stuff I'd ever have you guys do right now is still just algebra. We're not going to get into the on your own stuff until we get to triangles, which we'll start those next week. Okay. So looking at this one here, it tells you that angles 1 and 2 are complementary. If something's complementary, what kind of an angle is created? 90-degree angle. Okay. So I know that just from that statement, I can go to my diagram and I know that these two have to make that little right angle. So I put that little box there, just so I know that's what's going to happen. Okay. It then says that 1 and 3 are the same and 2 and 4 are the same. So why not also 1 and 3, 2 and 4? Okay. Single tick marks for 1 and 3 is doubles for the 2 and 4. So why did they write down 1 and 2 are complementary?
So we know that it's
because it's given. Why did they write this down? Oh. It's given. Oh. Okay. Why does angle 1 plus angle 2 equal 90? Definition complementary. Very good. All right. So far, so good.
Wait, what definition of right angles?
No, because you're given complementary. You always use what you're given. Okay. If they said angle 1, but no, I don't know. If they said like angle A is a right angle, then you could say angle A equals 90 for definition of right angle. But in this case, they're giving you complementary, so you utilize it. Next one, it says 1 and 3 are congruent, 2 and 4 are congruent. Why are those written down? They're given. They're given. They're right here. You can use it as many times. I don't know why the computer's so laggy. Okay. Now, what allows you to switch from congruent to equality? Perfect. Definition of congruent. Notice the only thing that changes for this next step is they got rid of congruency.
Oh, you're so good.
Something. Okay. Now is when you have to start. Up to this point, basically everything has been on your progression sheet. Over half of the proof is complete now. We need to figure out what is going on after it. So what we do is we start looking at what already has been written down. A second here. Something's open that shouldn't be open. Anyway, so this is the time when you have to start looking back and like referencing what's already been said. In this step here, you'll see that 3 and 2 are 90. Somewhere above that, didn't something else add up to equal 90? 1 and 2. Now, the difference between this one here and this one here is what? What changed? What was it? 1 and 3 changed. Well, why can you change 1 and 3? Because 1 and 3 are the same. Okay? You have to use substitution here. This is when you start looking at what happened. And I think I said this last week also. Substitution usually is that one that gets used a lot. If you're not sure what happened, take a guess and just write down substitution. You probably got a 70% chance of being right. And that's not bad. Okay? Same thing with the next one. You went from 3 plus 2 is 90 to 3 plus 4 is 90. Well, what changed? See how the 4 and the 2 switched? The reason that those switched is because we already said that 2 and 4 are the same. So that means you can substitute in for one another. It does not matter how many times you use one of the steps. Multiple givens, multiple definitions, multiple substitutions, it does not matter. And lastly, this is one that we really didn't go this direction with. Remember how we talked about before with definitions? If two angles add up to equal 90, they're complementary. If 2 angles are complementary, they add up to equal 90. The regular and then the converse of it, if those two were true, it was a definition. This is another version of saying this. Since we know those two add up to 90, that's the definition of being complementary. So this is just definition of complementary. Okay. It works going both ways. Start with complementary, say the angles, and go to complementary. It means the same thing. Okay? And that's what it looks like. All right? Not terrible? Are you close-ish? Hey, if you got the first 4, that's good. Did you get the first 4? Yeah, you get those first 4? Okay, then you're fine. Seriously, that's more than half. Okay? Think of it that way. Think of it in positive. It's more than half of it. You only had to kind of come up with 2 of them. Gentlemen, come on. All right? That's what I want you guys to start to realize, that this isn't supposed to be as deathly evil and scary as most of you guys make it out to be. It should be everything that you know is on that progression sheet. It's just a matter of finding it. Okay? Along with that, flip this over now. I want to start talking about some more of the other types that we deal with. And what I was trying to do with these problems here was to get some that had. It didn't work. I thought it snapped. So one of the things I want you guys to see just so you guys remember also, angle addition yes ma'am. Oh, sorry. I thought I had enough going back there. Would you send this one back, please? Remember, angle addition is basically the exact same thing as segment addition. It just has more letters. So remember, it's going to be smaller angle plus a small angle equals a bigger angle. The only thing that we remember has to happen is that they all have to have the same vertex. They all have to have that same middle letter. Okay. So what happens here with angle addition? It's basically we have W, X, Y, Z. Are you guys okay that there's three angles here that share the same vertex of X?
Yeah.
So I can say that WXY plus YXZ equals the large. We've done that before, we just never wrote it out in terms of what all the letters would have been. So I would just write angle WXY plus angle YXZ is angle WXZ. Like I said before, the downfall of working with angles, there's so many letters and symbols. That's the only downfall. The mathing of it is really quite simple. It's just that you have to write out a lot of letters, okay? That's the only thing that's bad. All right, so that's why I try to do as many of these simpler fill in the blanks so you don't have to write out as much. When I'm looking at this one to start out with, as I'm looking at this one as I'm starting this out, notice how they start the problem and what happens in the middle and then how they finish it. See how the problem starts incongruent, ends incongruent, but all the math in the middle is in equal. How do you switch between? Do you remember? Definition of congruent. So right off the bat, you know that somewhere that had to happen at least once. Okay? So you have your given AEC. I would mark my diagram. AEC and angle DEB. Those two are the same. In just marking that off, what angle do those two larger angles have in common? See how they have that middle wedge in common? They've got that BEC in common. So if I got rid of that middle wedge, wouldn't you be left with the outer pieces? Right. So if you think about it, if this was 50 and this was 60, what would that whole angle have to be? 110, right? So if these two are going to be the same, if this is 60, this has to be 50. So the idea is I can take out that middle via lettering, not worrying about numbers, okay? That's where the proof stuff comes into play. You can use letters instead of using numbers. So why did they write this down first? Give it, okay? Should never get that wrong. What changed between the first and second step? Turn into equal. So how do you change it from congruent? There you go. Okay. Now, it talks about one angle is made up of two other angles. That's a pretty dead giveaway of what? What kind of addition? Angle addition. Not segments, because they're angles. So angle AEC, AEB, BEC, okay, we got that. Angle DEB is made up of two smaller angles. What do you think that one is? Same thing, isn't it? Now, up here, we referenced that these two are the same, didn't we? which means the parts that make up them also have to be the same. So you used, I think you just said it, substitution. Good. You put these two equal to each other because these two are equal. So that's substitution, putting something in for something else. Now, second hour kind of got mad at me because of this next step, because it didn't really show it. What happened? How do you take something out of both sides of an equal sign? Subtract? Yeah. What happens now, when we did algebra, we had to show each and every step all the way through, and then we would simplify. When you're doing it in terms of letters, with segments, or with angles, you don't need to show the minus on both sides of an equal sign. Here, if it jumps from here to here, notice that these things both dropped out. In order to drop those out, it had to be minus prop equal. Okay? Then lastly, definition of congruent. Yep, it's switched. If it just switches, it's just definition of congruent. So going back and looking at this proof via what you know on your progression sheet, you know how to write down a given. You know definition of congruence. That example is there for you. So there's three of the steps. You also now have angle addition. You know that two smaller angles add up to equal a larger. There's two of your steps. So really, all you had to come up with out of these, let's see, 1, 2, 3, 4, 5, 6, 7 of them were two steps. Everything else is already there for you. Okay? It's a matter of getting used to it. And it should not be all that tough. Okay? Everything's there. I did forget to mention, we will have a test-ish thingy on this stuff on Wednesday. Sorry, I almost said Tuesday. I mean, it's scary. With that being said, what'll be on there, it'll be fill-in-the-blank style proof, just like we've been doing. Okay? We're not ready to do, we won't do, in chapter 2, we don't do anything that's on your own. We don't do that until we get to triangles. Yes, you will be able to use that, because I always let you guys use those for proof tests. You won't get that on the final, but we'll talk about that later, because the final part, when you get to it, it's, when you do a proof on the final, it's multiple choice. Okay, so the idea here, by then, it's pretty dang simple, because you can see what happened, you'll have the different properties, and you'll be able to figure it out. So it's not really all that work. We're not really worried by that point, but for now, we try to use these things. What I want you guys to do this evening, though, is there's 3 more that are on here. The other 3 are all dealing with segments, okay? Every one of those is a segment. Now, from that, excuse me, I wrote out all of the steps. You guys just have to come up with some of the reasons. All right? Remember, about over half of each proof is probably somewhere on your progression sheet. Usually all you need to come up with is 1 or 2 extra steps. When you're doing these things, make sure you're marking your diagram as you go through and filling in the blanks as you go along, okay? You've got a good 8-9 minutes to get started, so please do so. Okay? We'll do some more angle ones tomorrow. I've got a couple left. So let's figure out Wednesday.